Last lesson of chapter 4 we're going to look at is determinants. Determinant of a square matrix, because we can only take the determinant if it is a square matrix. 2 by 2. Every square matrix can be associated with a real number called its determinant. Determinants have many uses and will serve discussion. Historically, the use of determinants arose from special number patterns that occur when systems of linear equations are solved. For instance, if we have this system, we can solve this for x by taking the determinant of our corresponding matrix of our numbers here, B1, C1, and we can solve for y by taking the determinant of this here, divided by the determinant of our coefficients, our coefficient determinant, which would be these here. And it does give us a solution. Now the coefficient matrix, A1, B1, A2, B2, is the determinant is A1, B2 minus A2, B1. This product subtracted from this product. And by definition, we get this here. The determinant of A matrix A with absolute value bars with matrices, is understood to be a determinant. A1, B2 minus A2, B1. Although various numbers, we can have this cross determinant. Determinant of this here, positive, negative, 0. Now our first example is this here. So for matrix A, I know it's small on your paper. I did it that way just so we can make sure that we have, we're just not wasting paper. We can take this here. So it's left diagonal minus right diagonal. So for us, we'd have 2 times 2 minus negative 3 times 1. 2 times 2 is 4. Negative 3 times 1 is negative 3. And our negative makes a positive. 4 plus 3 is 7. We can do the same thing with B. We have 2 times 2 minus 1 times 4. Well, 2 times 2 is 4. 1 times 4 is 4. Telling us that we have 4 minus 4, which is 0. Our last one. We have 0 times 4 minus 3/2 times 2. And luckily this one's still pretty nice to solve because 0 times 4 is 0. 3/2 times 2 is 1. Because 6/2, or what happens with, because we do 2 times 3 is 6. 6 over 2 is 3. 0 minus 3 is negative 3. So the value of the determinant can be positive, negative, or 0. Questions on determinants? They're not too bad. We do.
Kiana Brown, please come to the office. Kiana Brown, please come to the office.
This product minus this. We get this here. The determinant of a matrix of order 1 by 1 is defined simply as the entry of the matrix. For instance, if the matrix A is equal to negative 2, then the determinant of A is negative 2. If it's a single number, its determinant comes back just as that number. Minors and major coefficients. Minor, major, so there is a way to do this. Cij, as the entry of ij is this here, negative 1 to the I plus j, row column, times mij, where it is the minor here. And the signs change as we get bigger. It's this positive, negative, depending on the row and column. So if we looked at this here, and we'll come back to it, we would say, so the first one, 0, is what we have. And we do this with each row. So we take each row individually. So when we take 0, what it leaves us with is this smaller matrix, which is a 2 by 2. And what we have is we take that matrix here. So what they're doing is this cross, -1 times 1, minus 2 times 0, giving us -1. So our M11 would be this here. We do it again with M12, and we get all of these here. And we can go about finding the coefficients. Now, this works out well, especially if we have several zeros. We did this already in Algebra 2. We wrote the 2 out to the side and did our diagonals. Or the third way is we can actually use the calculator. Because again, we can go second matrix over to edit. And this one here is a 3 by 3. Yeah, I was either going to have you read it out or let me see it. And we have 0, 2, 1, 3, -1, 2, 4, 0, 1. And once we get it typed in, we get the matrix typed in, we're going to go second matrix and over to math. And what we want is DET. DET is going to be our determinant, second matrix A. Enter. It tells us the matrix determinant. The determinant of this here is 14. So we can add all those together as previously defined and get that there. And that's it.